Hello again. Today we're going to be looking at another exciting topic on basic science. And the topic today is gravitation and weightlessness. Now, because of the topic is actually very short, I would like to add up with satellite to talk about satellite. And so what we're looking at is gravitation and weightlessness as well as satellite. Now, this aspect of basic science is mostly on, we can call them that earth and science. Yes, earth and science. So that's the aspect of basic science, all right? And we have a whole lot of things to look at under this particular topic. And let's quickly look at our content for today. Our content is, we're going to be talking about the meaning of gravitation. That is, what is actually gravitation. We're going to talk about the gravitational force. We're also going to look at things that actually pulls the earth. Of course, you should know by now that when we're actually talking about gravity, we're actually looking at things that pulls on the earth. And then also number two, we're going to be looking at the meaning of weightlessness, okay? We're also going to be looking at the effects of gravity on objects. Of course, there is an effect of gravity on object. And like I told you again, we're going to be talking about satellites. We're also going to be looking at the meaning of satellites. We're going to talk about planets and their number of satellites, mostly natural satellites. We're also going to be talking about natural and artificial satellites, and then we'll look at the types of satellites we have, both artificial, mostly artificial, okay, types of artificial satellites. So these are some of the things we're going to be discussing in this wonderful topic on gravitation and weightlessness as well as satellite. Now let's begin with this. Gravitation. You know, most times some scientists or most science students become curious. I was actually reading a book once, and I became curious of the hypothesis some persons put forward, or mostly the questions asked by one of the scientists when he saw an apple fall from the tree. And most times I ask, why can't I throw something up and the thing keeps moving up? Why is it always coming down? And why is it when you go out of this, the earth, okay, the earth atmosphere, and then you go into outer space, you will discover that the gravitational pull of the earth is no longer there. You float, okay? You become apparently weightless, all right? So that's all we're just discussing today. And that brings the law of gravity, the law of gravity. And many scientists have done so many research on this and come up with a whole lot of information about the gravitational force or gravity. Now, gravity or gravitation is actually a force that has effect rather on the stability of a body. It has effect on the stability of a body. In fact, all objects on earth, both living and non-living, assumes stability based on the gravitational effect of the earth. All right. Now, if an object is tossed up the air, it will fall back to the ground because the earth exerts attraction on it. Now, why the attraction is there, that I can't tell, but the earth has a massive force of gravity that pulls whatever goes up, it pulls it down, always pulls it down. In fact, for objects to actually overcome the gravitational influence of the earth to escape to outer space. In fact, that velocity is what we call the escape velocity. It is actually the velocity needed by an object to overcome the gravitational effect of the earth. Okay, so once you can overcome that gravitational effect, then you can go outer space. Hence, most scientists have built aircrafts and shuttles, jets and all that can go above, that can beat the gravitational influence, or that has an escape velocity that can propel some machines above the gravitational influence of the Earth. Now, note that this attraction from the Earth, this force of attraction from the Earth on every other object is called the gravitational force of attraction. It is called the gravitational force of attraction. Now, note this. The amount of force with which gravity pulls on objects in the Earth depends on three important factors. Now, number one, it depends on the mass of the object. And that is why we have different weights. We have different weights because of our varying masses. We have different masses, okay? We have different masses. So the pull of the Earth on objects is dependent on the mass of the object. Number two, it depends on the mass of the Earth. Number three, it depends on the distance between the center of the object and that of the Earth. So distance and the mass of the object and the Earth makes three important factors that depends on that depends how the gravity pull of the Earth is exerted on any object. Now, take a look at this. Now, the gravitational force of attraction between any two objects increases as the two objects approaches each other. So, as they approach each other, their gravitational force of attraction increases. Number two, the Earth has a gravitational pull because it has a great mass. The Earth has a gravitational pull because it has a great mass. And then number three, the gravitational pull of the Earth is always directed to the center of the Earth. Now, if you could also remember what we just mentioned about the three factors that depends on which, or that depends on the amount of force of gravity that affects an object. Remember, we just mentioned three: the mass of the object, mass of the Earth, and then the distance between the center of the object and that of the Earth. Next, we're going to be looking at talking about weightlessness. We're going to be looking about weightlessness. Now, weightlessness is actually the apparent feeling of being weightless. Now, most times when objects cross the Earth's atmosphere, remember I just mentioned about the escape velocity. So when the object crosses the Earth's atmosphere, it is free from the gravitational pull of the Earth. And once it gets there, there is a feeling of weightlessness. In fact, not just a feeling, there is an experience of weightlessness. Now, when we say an object is weightless, it means it does not have any weight. And so, if the object is actually tossed up, it means it will keep going up. Nothing to pull objects down. So objects begin to float in space because of no gravity, or because they are no longer under the reach or the effect of the gravitational pull of the Earth. All right? So that is what we mean by weightlessness. It is the feeling or apparent feeling of being weightless. The apparent feeling of being weightless. That is what weightlessness is. Next is effects of gravitation on objects. The effects of gravitation on objects. Now, one effect of gravitation on objects is stability. Remember I mentioned something about stability when we talked about gravity or gravitation. We said that gravitation affects the stability of objects on Earth. So it means that the stability of any object is dependent on the force of gravity. Now, it helps every object in the Earth, including man, to remain stable. So you can stand at a place without tilting to the end or without falling to the right or the left. You have stability because of what? The gravitational force of the Earth. We also, our cars, our buildings, all have stability because of the gravitational influence of the Earth. Number two, Gravity brings about the weight. In fact, it decides or determines the weight of an object. Now, the weight of an object is a measure of the gravitational pull of the earth on that object. In fact, weight can be defined as a force that determines the pull of the gravitational force of the earth on objects. Okay, that's the weight of an organism. So it is dependent on the gravitational pull of the earth. Now, another effect of gravitation on objects, on life, is that it brings about the revolution of the moon round the earth. Now, the moon moves round the earth. It revolves round the earth. Now, what helps the moon to revolve round the earth is the influence of the force of gravity of the earth on the moon. So the moon is able to revolve round the earth because the gravitational pull of the earth attracts it. So it is based on that attraction that helps revolution of the moon round the earth possible. Next is balance. Balance. So balance of planets in our solar system. Remember, we also said, if you could check some of our videos, mostly our videos on Earth and space, okay, we mentioned something about revolution. We also mentioned about rotation. Now, the Earth rotates around its own axis, of course, and which brings about day and night. And I have just mentioned to you also that the moon revolves round the earth. Why? Based on the gravitational pull of the earth. Also, the planets revolve round the sun, also because of the gravitational pull of the sun and other planets on each other. Now, look at this. The sun and all the planets in the solar system exercise gravitational pull. So the sun and all the planets, including Earth, they exert gravitational pull on one another and mutually balance on another in space. So they have a particular balance. There is no way the Earth can shift out of its particular space. It has a space it occupies. Now, why does it maintain that particular space? It is simply because of what? This balance based on their gravitational pull. So the Earth can revolve around the sun. The other planets also can revolve around the sun in several dimensions, in several speed, and so on, based on their gravitational effects or influences on each other. It brings about a balance. It brings about a balance. And then number 5, work is done against gravity in lifting an object from the earth. Yes, of course, we can lift things. Now, how do we lift things, or what brings about the lifting up of things? It is still the effect of gravitation. So when the energy you're exerting to lift up a particular object is greater than the gravitational pull of the object on the object, then there is every possibility for work to be done in lifting that object above the ground. Okay, above the ground. So you can see on the screen, the object is 50 kilogram in mass, and then the gravitational pull is 500 Newton. For you to be able to lift and sustain it in that particular position, it means you must generate an energy source or a force that is actually greater than the force of 500 Newton. All right? So it brings about, in fact, the effect of gravity brings about work to be done. Work cannot be done without the influence of gravity. All right? Now, moving ahead, we are done with gravitation and weightlessness. Let's quickly look at meaning of satellite. Let's look at satellite, and we're starting with the meaning of satellite. So what is satellite? Now, satellite is a body that orbits, that is, moves round a planet. Any object that moves round a planet or body that moves round a planet is referred to as a satellite. We have different examples of satellites. We have the moon, which is also an example of a satellite. We have weather satellites. Okay, yes, we have weather satellites. They also, they are objects that revolve round. These are mainly artificial satellites. Okay, now let's take a look at some of them. We have planets and their satellites. Let's look at the planets and their satellites. Now, of course, we have the 9 planets. Recently, scientists said that it is 8, no longer 9. And the reason for making it 8 is because Pluto has been discovered to be a dwarf planet, is a dwarf planet. And the biggest or the largest planet is actually Jupiter. But we have, well, let's look at all these planets. We're still looking at the 9 planets, and we're also going to see the number of satellites, mostly natural satellites, that orbits around each of these planets. The first one is Mercury. Now, Mercury is the closest to the sun, and there is no satellites orbiting around Mercury. The next is Venus. Now, Venus is the next planet close to the sun after Mercury. Now, Venus also do not have any known satellite, which is the moon. It doesn't have any known satellite. And then number 3, we have Earth. Now, Earth is the 3rd planet, and which is habited by living organisms, and it has oxygen in it, present in it to sustain life. And Earth has only one satellite, and that is one moon. And then number 4, we have Mars. Mars, which is the red planet, it has 2 satellites. We also have Jupiter, probably the biggest. Jupiter, it has 79 known satellites. It has 79. Then we also have Saturn. Saturn has about 82. We have Uranus. Uranus have about 27 known satellites. We also have Neptune. Neptune has about 14 satellites. And then Pluto has about 5 satellites. So please take note of these different types or different numbers of satellites orbiting around each of the 9 planets. Now, natural and artificial satellites. Natural and artificial satellites. Now, the moon that orbits the planet in a solar system are called natural satellites. Now, natural satellites are satellites that are not made by man. They occur naturally, and they orbit around each planet. They orbit around planets. So we're looking at the natural one, which is called the moon. We also have the artificial satellite, which is made by man. Now, these ones are sometimes launched by various countries, and they orbit around the Earth. We also have several examples of countries. We have years of first launch. We're also going to be looking at their first satellite. The first one on the list is USSR, right? Now, USSR actually were the first to launch a satellite. They were the first to launch a satellite, and they did it in the year 1957. It was done in 1957. And the name of the first satellite is the Sputnik 1. The second one is designed or launched by the USA, United States, and it was in 1958, a year after the launch from the USSR. And it is called Explorer 1. We also have the Australians. Australians also launched the other in 1964, which is called the Blue Streak, followed by France in 1965, which is called Asterix, followed by Japan in 1970, which is the Osomi, and then China also in 1970, which was their year of first launch, and that is called the Dongfanghang 1. We also have the United Kingdom launched theirs in 1971, and is called the Prospero X3. And then India launched theirs in 1979, which is called the Rohini 1. And then Israel also launched their first launched their first satellite, artificial satellite, in 1988, and it's called the OFEG-1. And then Nigeria also launched their first satellite in 2003, and it is called SAT-1. So these are the different countries, their years of first launch, and the name of the first satellite. Now let's look at some of the types of satellites and their uses. The first type of satellite is called the astronomical satellite. Astronomical satellite. Now the astronomical satellite is used for observation of distant planets. Use it to observe distant planets, galaxies, and other outer space objects. Number 2 on the list is called the biosatellite. Now, the biosatellites, they are used to carry living organisms, as the name implies, bio. Bio talks about life. So they are used to carry living organisms, especially for scientific experimentations. All right? Number 3, we have observation satellites. Now, observation satellites are used for geographical studies. They are used also for photographing. They are used for photographing areas. They're used for map making. So most persons that make maps, most persons that photograph a particular zone or area, they use this observation satellite. And then we also have the weather satellite. And as the name implies, it is a satellite that helps to monitor weather conditions in the atmosphere and supply information to ground stations. And that's where we have the meteorologists talking in the news rather, and in social medias telling us the condition of a particular place, what will happen, the weather conditions, and all that. So how did they get to know this? Is using the weather satellite. And then we also have the communication satellite. Communication satellite. Now, it is actually designed for the purpose to send information quickly from one place to another. So it helps in the dissemination of information. And then we have also the reconnaissance satellite. Now, the reconnaissance satellite is actually for the military. They are used for military or intelligence purpose, such as observing enemy locations and troop movements and all that. It is actually a military hardware, all right? And then we also have the space station satellite. The space station satellite is actually designed for humans to live on in outer space. So humans inhabit there, make 1 or 2 discoveries and all that. They are only designed for periods of weeks. Some persons stay there for months or even years, all right? Not a permanent stay. Then we also have the navigational satellite. Now, navigational satellites are satellites that use radio time signals and enable mobile receivers, like in your phone calls and all that, helps in mobile receivers on the ground to determine exact locations. So these are several satellites we have. We've been discussing quite a whole lot of things for some time now. We've talked about some of the, we've looked at the satellites, we've looked at the meaning of satellites, we've talked about the types of satellites, we've also looked at the natural satellites, we've talked about the artificial satellites, we've looked at the number of planets and the satellites that orbits around them. We've also mentioned some of the countries and their first launch of their satellites and the names of those satellites. We've also talked about gravitation, and then we've also mentioned weightlessness. And finally, we discussed on the effects of gravity. And this is where we're going to call it a wrap up on this particular class. I'll see you in our next video. Bye for now.